radio. Hi everybody, and oh, by the way, welcome to the Keshe Plasma Reactor group for Tuesday, August 2nd, 2016, August 3rd in some parts of the world, but not where I am. And yeah, we're just talking about some of the confusions of the world and how sometimes systems don't mesh, I guess. So anyways, let's carry on there with what were you saying there, John, exactly about what we were just saying while we're
Oh,
on the
we were
live
just
stream?
talking about quality of microphones, and we got a fella in tonight that unfortunately, I'm sure he's got lots to share, but we just can't understand what he's saying because his microphone is. It sounds like he's talking through a tube on an old World War One aircraft radio.
Yeah, from
Real-
somewhere in the trenches, crystal radio set, basically. And it's
Yeah, we were.
strange, in this modern day and age, you would think that it would be a truly a no-brainer in terms of all of our communication technologies. I mean, you would think it would be simpler and simpler and simpler, but it's become more and more and more complex with competing technologies and definitely conflicting, not just competing, but conflicting technologies that are all vying for our attention on all these different platforms and different fields and so on. And when it comes right down to it, it's hard to get good, clear audio consistently all the time, especially if one lives in Italy and is trying to get it out to the rest of the world, for example. But no matter where you are, things just go weird. I have strange audio problems constantly, and I use a Mac computer, is supposed to be good with audio, and they are generally, but you try to combine this with live stream with this and Zoom, and there's too many competing variables and mixing technologies. So it'd be nice if we had something that worked for everything, maybe a different type of technology, and maybe that's where plasma type communications will start becoming more prevalent. I'm wondering, it might not be possible to have the plasma technology and the existing electromagnetic wave technology in radio stations and that kind of thing existing side by side. That's remains to be debated. But for
Well, we've been
now,
working, we've
sorry,
been
go ahead.
working, we've been working with Bridge Tech. We've been working with bridging technologies for the last 2 years to bridge the plasma into the conventional systems. I'm sure that there's going to be a transition period in there where we'll have both systems running parallel for a little while.
Well, I think, like in terms of, for example, with the Tesla system, the way I understand it, and when Tesla came out with his broadcasting energy around the planet idea, and it was kind of poo-pooed by the financiers at the time, it would have interfered with the other type of electromagnetic radiation in that it was more like, for example, if you have a spark-based transmitter, it'll overwhelm other transmitters, so they don't allow spark-based transmitters to be transmitting the way they did initially when they were first had radio stations and so on. Because it's so broad spectrum, a spark will put out a wide spectrum of electromagnetic fields that will interfere in all kinds of levels, actually. And so it's interesting, anyways, that in this modern day and age, we still have communications issues. But anyway, I just wanted to expound on that a little bit because it's amazing to me. It's just, you know, we still can't, like, for example, AM, FM radio. I get into my car and turn on the radio, and 9 out of 10 stations are fuzzy. I can't listen to them. This is, at least, isn't it at least 1980 by now? Or something like that. I forget. I think it's in maybe even in the 20th century by now. You would think that, after being at this for 100 years or so, they would be able to broadcast so there wasn't any static and you could actually hear the stations and not have to. Anyway, it's whoa, it's a strange one, and I've got no other choice. Satellite radio, maybe of it. I don't even think that works here. Anyways, let's not go there. Let's go to Lee Coates instead and see what he's got going there, because we all love fancy, cool-looking apparatus here with wires and levels and coils and bottles and plasma and all kinds of stuff. And we see someone's head sticking over the top of this huge apparatus. How you doing, Lee?
I'm doing great.
And of course, we want you to explain what the heck you've got here this week. Holy cow! It's in an engineering kind of way. It's beautiful. It's I love your. Are they plexiglass discs or are they acrylic?
Yeah,
I guess or
acrylic discs.
yeah.
So I got a plexiglass pipe frame on here. It's elongated cube basically, and I filled it with little plastic things and put the photo water in there, like Mr. Keshe was saying there 2 or 3 weeks ago. And
So
and
is
then I
that
used some little
filled?
spacers in here to.
Sorry, is it filled all the way? Those tubes with fluid?
Yeah, it's filled all the way. There's a T and a little filler on each side.
Okay, cool. Thank you. Yeah.
Okay, and then this piece of plywood just slips over those 2 tubes so that the top part's sort of different. So I got my little trays here. I got this is from the blueprint that was handed out there about 3 weeks ago or so. I got the copper coils top and bottom with the 3 nano-coated coils in the middle, and then on the inside there we got a glass ball and a spinning plastic ball in the middle of that, and inside the plastic inner ball there's a spinning paddle, and inside that shaft there's this the wire on top goes down for the collect any power from inside that ball. So we got a shaft within a shaft, and then the wire inside the other shaft. So I used a 3/4 inch copper pipe for the outer shaft,
Okay.
which meant I had to get a 7/8 bearing for it to sit on. That's what this plywood box up top here is. So I got a bearing top and bottom.
Oh yeah. Okay.
So it doesn't wobble or whatever, because that's the trouble I was having on some of my other things. The bearings were too close together.
Yeah.
So they're nice far apart. The only problem is those 7/8 bearings. I bought them at Princess Auto, and the only thing I could find was 7/8 was like industrial quality, and they got some resistance to them, and my little motors here are having a hard time spinning.
Yes, absolutely. They need an industrial quality motor. I know what would work good with that, but go ahead. Yes.
So I just turned it on today, and the max RPM I can get on that outer shaft is about 400 RPM.
Right. What kind of motor are you running? What kind of motor are you running there? Sorry, I'm not hearing.
One I bought on eBay there about 6 months ago. I forget what it is. It's one I bought on eBay there about 6 months ago.
One of those
I think it's only
surplus.
a 2,000 RPM motor.
Oh.
Surplus motor. It's a fairly big skookum one. I think I paid $20 a piece for it or more.
Okay.
But it had a little pulley on the top, which I'm driving the big shaft with a small pulley, which means I need a bigger pulley on there to get the RPM up. But I think there's too much resistance in here to spin it. So I got that. So I got a little problem there. I got to fix up and.
Yeah, Lee, have a look at the brushless model airplane motors. You'll get a lot more torque out of those, and they're much more efficient than those little beater cheap hobby brushed motors.
You'll have to gear it properly with a belt or whatever to.
This is more like an industrial brushless motor. It's not a cheapie.
Okay.
So, but anyway, I might have I'm going to have to do something here. Those motors won't
Yeah, if you want a nice heavy duty motor that's fairly readily available at your local thrift store, is a sewing machine motor. And I've had good results with my little singing sewing machine motor. I won't mention the brand name. Well, it's Singer. What the heck? It's sewing machine. It's renowned sewing machine in this part of the world. And we will give a little picture of it here just so you can see. We don't
Is
have it
that
hooked up.
is that a variable speed as well as reversible?
This one
In Lee's or with the.
No, yours. Your sewing machine motor, is it variable speed and reversible?
Well, actually, I don't think it's reversible. There we go. So this is the actual sewing machine motor here. I'm just getting it rejuvenated. I just put the belt back on this system here, and I see there's no. I'm not sure we had it plugged into it. Oh, is that the plug for this one? Or? That could plug in right into the Variac, or it's a long way to go though for that. I don't know if you can reach there, Guy. But yeah, and this
One of the things
gets.
you really need to watch out for when you're picking motors is get motors that are designed to run at various different speeds. A
Yeah.
single speed motor, if you try to lower the voltage and run it slower, it's really hard on the motor.
Well,
Airplane engines, sewing machine motors, they're intended to run at oddball voltages all over the place.
yeah, that's right. It's got a little foot control that normally you plug into. I'm not sure where that even is right now, but we've run it into a Variac, so you can just turn the voltage on and vary the voltage. But
Fan will run at lower voltages too.
pardon me?
Fan motors will run at lower voltages.
Yes, and quite often.
90 volts.
Yeah, quite often like this one, it'll have a little built-in fan inside here that'll add to the cooling, so it still cools even at lower RPMs. Is it? Maybe it's not plugged in or whatever. Okay.
He gave the cut sign.
Oh, yeah. More plugs all over the place here. Yeah, I'm not
When he
sure
starts,
if that's.
shaking, what happened?
Not sure if that's gonna reach either. There's stuff all over the lab here that makes it a little difficult to get around at times. We have a new little thing that we're speaking of shafts and so on. This is exactly what Guy and I were working on earlier with this little contraption, which is boy, there we go in there, a nice suction fit. This is a Pyrex nice lab flask. It's actually called Alchemy. It's the brand, the company. Alchemy is nice. And this is not just any old wine glass. First of all, it's indestructible. And it's actually not acrylic, it's polycarbonate. And you could probably drive over it and not break it. And so we're combining technologies, the covering of a bulletproof polycarbonate with the somewhat fragile but still pretty tough glass, and also giving another layer of, well, both the plastic versus glass, but also in between there's the possibility of adding plasma fluids, liquid plasma basically in between as a thin layer, especially where it pinches right here is an interesting point where that thinness of the layers and the atomic layers might just have a special effect there. And the other special thing about this is the top, which is it's able to take a shaft. It's actually got seals in here, and this is to vary the pressure on the seals. You can squeeze this in or out. It puts there's a spring in there and it puts pressure on these seals, and it's made to take, I believe it was a 3/8 inch usually it'd be glass shaft that goes through. So we're going to rig it up with a shaft that goes through and a little ball that goes inside of this.
Like this
So
guy.
yeah, like this guy here, which is nice little glass sphere. And the thing about this is it was designed as a ring. I don't know why people would wear a ring like that, but apparently some people do with their boyfriend's hair or something in there. And it's got a nice, be nice if it focused, threaded fitting anyways, in the end there. And this has got the threaded part which goes in. So right now we're trying to find a shaft that's either already hollow and threaded that'll fit right into there, or some even the solid shaft will work for us. And this fits really nicely right down inside the neck of this to be able to exist in the center part or anywhere we wish inside there. And I think this will be enough rotating at high speed to rotate the fluids in an interesting way inside of our sphere as well. So there's lots of different ways to look at that. And again, the challenge is similar to what Lee is facing. How do you get all these shafts to work together? And especially, what if you want to create a vacuum, which is the way I like to go. This can be all vacuum sealed with the proper setup, at least at a good partial vacuum, if not full vacuum, let's say. So let's go back to Lee there, and oops, I think the camera's moving around. And we're getting we're getting a different view of your setup there. Okay, yeah. So yeah, explain more. That's pretty cool. I like the
So I
belt
got
drive.
this is the bushing on or the collar on the bearing on the 3/4 inch copper pipe shaft. Then I got a 1/4 inch copper tubing on that shaft and going down the inside with some 3/4 inch by 1/4 rotor bearings on the in between. And then we got the wire going down the middle, and it's just got a little plastic bushing that I made just so it's not rubbing top and bottom.
Okay.
So,
Wow, that's cool.
so I don't know what
Any
else there is to show here other than.
Well, have you actually run it? Have you actually run it? Has it done anything yet, or?
As I say, I just ran it this afternoon for the first time, and then
Yeah.
say that I could only get up to 400 RPM on the ball spinning inside, and I had about 1200 on the stirrer inside the ball.
Mm-hmm.
So, but I can change the pulley sizes here to up to like this one's run by a little wee pulley on a big pulley or on the collar there, and that's part of the problem. But the other part is the motor's not powerful enough.
Right.
Well, I think you might find after running it for a little while that it'll loosen up a little bit. Usually those bearings, especially new ones, they have a packing grease in there that's really thick. And typically when I was doing tool and die making, working with that type of bearings, we'd wash the bearings out and replace all of the lube in the bearing. And then they loosen up really, really nice.
Good point. I often would just spray a bit of spray lube in. That would dilute the grease in the bearings. I've even taken the grease out and sprayed silicone seal into the bearings and let that not silicone seal, pardon me, silicone spray. How
do you get the rubber seal off the end of the bearings? Just pry it off, or
you
what?
can pry that off with a little tiny flat bladed screwdriver, or a tip of a knife or something.
Okay.
Yeah, it's just
hard.
a press fit
It's
into
hard to get.
a little tiny groove in the outer race of that bearing.
Yeah, it's hard to get them out without distorting them, but it is possible.
Even sealed bearings, if you just run them for a while, they will loosen up. You got to be careful when you're putting lube in a bearing, though, because the tolerances are typically so tight that if you put a lube in there that's too thick, you're going to generate a tremendous amount of heat.
Yeah, not with Princess Auto bearings, so they're loose like a goose. But the thing is, they need run-in time. You're absolutely right, because the balls, everything is a little on the there might be a little oblong or whatever, and they need their run-in time just to get all their clearances good. And even then, it's just not the best way to go. There's something to be said for the word precision miniature bearings, which are
Yes.
available. But they get more and more expensive the higher up you go. And of course, the best ones are the ceramic bearings, I think, that are non-metallic and don't interfere with the magnetic fields that way. But they can be 70, 80 bucks a bearing or more, so it gets to be out of sight then. It's for space age projects, which maybe soon we'll have to be doing, but for now, as long as they're keeping on the floor of the shop, then so far so good. What
Yeah,
do you
so,
got
so
there?
just
What are you
run
showing there,
in,
Lee? Sorry, go ahead, John.
run your bearings in, monitor the temperature of your motor, try to keep it so that it's, if it starts getting too hot to touch, turn it off, let it cool off.
That's a good indicator. If it's too hot to touch, then you probably have overdone it a bit and time to let her cool down.
Yeah, but
That's my
probably
indicator.
5-6 hours of runtime, that bearing should should run in and loosen up a little bit for you.
That's about right, I'd say.
Okay, that the bottom copper coil on the blueprint, it showed a power supply on, or putting power to it, and I mean that's just a dead short basically if you tie power to the 2 leads coming off that coil. So I did not understand why they were doing that. Anybody got any comments?
That was on the which blueprint? The spaceship blueprint, you mean, or?
Well, the one Keshe came out there with 3 weeks ago. The one from Renan, I think it was, showing this.
Does
This
anyone
builder.
have a copy of that handy that we can show on the screen, or you see, where was that available? Where do I have that? I'm not sure if I've got it in my files here.
I think it was Armin's new setup. It was a nano-coat, a copper, and a nano-coat in wedge. He had it in a wedge, a 3 pancake wedge.
Or are you talking about a document, Lee, or are you talking about
I probably
Armin's?
took a screen share off the Knowledge Seekers workshop.
Do you know anything about that, Armin?
Yes.
He's sitting there patiently going, you guys, are you ever going to stop talking and just ask me? Why don't you explain anything that you might have noticed here, Armin, that you can help us with?
Okay. What's the question now?
The question is the lower bottom uncoated coil, according to Lee on the blueprint, shows that it's connected to a power supply, which would essentially create a dead short. And we're kind of confused about that.
Actually, if you, yeah, that's short because you connected to your electrical, actually to your grid. That's why it's that short.
Yes. And that's going to cause a lot of problems for a lot of people.
So the idea is not to connect it to the grid, correct?
Yes, this is off-grid system.
So could you connect the coils to themselves, or what do you connect to?
You connect the coil the same way, but you create actually with that, as Mr. Keshe explained, that we have an earth connection.
Would it be correct in assuming that the uncoated copper coils are acting similar to a transformer, picking up the magnetic fields coming off of the coated coils? Is that correct in this system?
Actually, the way he explained that it's an earth connection.
Right, I remember. It's an earth connection. So, but that doesn't mean you have to hook the coil up necessarily to the earth, right? It's just the copper coil itself acts as an earth.
Yeah, off-grid system.
Okay.
Right, but I mean, you wouldn't have to stick a post in the ground, and actually make a ground circuit or whatever it says. It's the copper coil itself, the bare copper coil, acts as the ground in this sense, right? As opposed to the plasma field around the nano-coated and so on. The bare copper is in that realm, it would act as the ground. Is that basically the way it works?
Yes, but the coils inside, it's middle coil is totally different. Let me explain. The way I did it, but I have so many projects, so I jump from one to another, so I forget to continue on that. 1 minute. Oh. Okay. We connect our coils here. We connect our coils all this way, correct? From right to left. So all in, gravitational and magnetical, they all go one direction, correct?
Okay, that's confusing.
What do you mean that's confusing?
Well, on the maggrav system, the inner gravitational of each coil loop is in one direction, and the outer coil of that same gravitational loop is, or in the magnetical loop, goes in the opposite direction.
No, it's not.
That's the way we've been connecting the maggravs up, or I have.
Okay, just explain how you connect your magravs. They all
Uh,
wind, all I'm asking you, they all wind it in the same direction, correct?
yes.
Correct.
That's what my question is.
Oh, okay.
Okay, but right now it's a different winding. So you go from left to right, right to left. This is gravitational coil. And upper coil, again, left to right, right to left.
And this is you're talking about the helix of the coil itself, correct?
Yes.
Okay.
We do kind of, let's say coiling, we do from right to left, correct?
Well, yeah, it's the issue is just in the words being used, because it's confusing when you say connection and coils. A lot of people are going to be thinking
Same.
not in the helix, but in the direction of flow.
Let me explain differently. How about that? You see this coil? Inside is copper, outside is aluminum.
Okay, yeah, I can see that the outer coil is wound back or wound in the opposite direction that we would typically do our maggrav coils in.
Correct.
Okay,
But inner is totally different direction.
all right, that makes sense. Thank you.
You're welcome. All right. So middle coil, it's going to be this one actually. I'm going to test. Nano-coated, and because middle coil. So what you do, if you have, I'm sorry, 1 minute. This way. You have your 3 stackers. Okay, these go all one direction. This one, it goes left to right, right to left. Left to right again, right to left again. And upper, it's all the same direction. So only the middle part, these 4 fields, it goes opposite directions.
Okay.
Then you have totally different.
To be clear, you're saying just the middle set of coils has the 2 directions. The upper set and lower set are all one direction.
No, let's say this one it's winded from left to right. Okay, upper winded right to left. Okay, goes one into each other. Correct. This one goes here inside this one.
Mm-hmm.
Okay? The same thing, and you connect the same way.
But does that form just the middle line of your 3 lines of coils you show there on the left? Yeah. It's just that middle one, right, that you're talking
Yeah,
about?
this is the middle one.
Okay.
Okay, these ones, they all go the same direction.
Okay.
You
Okay.
add.
And the ones on the top and bottom, are you putting aluminum on those as well, or just in the center one?
No, only one.
Okay. And how did you come to this aluminum copper winding the other direction conclusion? Where does the guidance come from that? I don't remember aluminum over copper necessarily.
Look at the, it's a gradient difference. Look,
Oh,
copper is
definitely,
65,
definitely.
aluminum, what is it? Aluminum, this is
I definitely a gradient
aluminum is
difference
26.
there. Mm-hmm.
It's half of it. Look the gap.
Sure. Mm-hmm.
I have a question. The top and bottom coils of the stacker, they are nano-coated. The center coil that you just showed in the different directions, that is left not nano-coated.
No, it's
So
nano-coated.
it's also nano-coated.
Yes.
Even the center one with the aluminum and the copper, they're both nano-coated.
Yes, correct.
Oh, okay.
Finish this up, following all the instructions and
Yeah, it's only the extra two top and bottom coils that are the plain copper. You'll have a 3-coil stacker sandwiched between two plain copper layer coils.
yes,
And I assume that the plain copper coils are the same as the top and the bottom of the stacker, correct?
correct.
Okay.
Try this one.
There you go, Lee. Something to do tomorrow.
That'll keep me busy.
Yeah. Yeah, interesting. Hmm.
What is the purpose of this reactor?
So, Armin, have you had any interesting effects that you've seen recently, or duplicating or experimenting with?
Now I'm trying to build a core which is properly actually functioning. So let me show you this.
Oh, Mario, to answer your question, this is the Model A of the standalone system.
Oh, okay, thank you.
Visualize these balls. It's like okay. Now I can, because 2, 3 I did, it was
Oh, that's gonna hurt.
those are acrylic balls, right?
So if I put water over there, it will.
Yeah, he'll centralize it then.
Yeah, but it's not wobbling that much.
Yeah. Well.
I shorten it, John.
Ah, okay, that's better. Yeah.
Long and it was wobbling, so this one is short now.
Yeah, try to keep the moment arm as short as you can, guys. It's so much easier to get everything balanced if everything's nice and compact.
Yeah, I actually recommend that people don't use those acrylic balls, because someone's going to get hurt seriously with them, because they are so fragile and they shatter totally when they break.
Well, when they shatter, they make shards, like
That's
sharp
right.
points of glass, and they at if it's spinning at 4 or 5,000 RPM, it will embed itself in your chest.
Yes, and they can't be X-rayed is the problem.
Actually, this one, I rotated around 10,000 RPM and had no problems.
Because it's full and it's balanced.
Yeah.
If it does come apart,
And see how
it's
you've reinforced it
gonna be
around.
dangerous.
The secret is what you've done there is to reinforce it where the join is between your brace there and the actual ball. That's so important. And
Actually,
sometimes,
I'm not looking to do this way. Just fun to make this kind of gadget.
yeah, it's so fun and easy. But the problem is people are putting acid inside and alkaline and strong alkaline, strong acid, and rotating it at high speeds, and it's going to cause trouble because it's not at all like polycarbonate. It is acrylic, and it absolutely shatters instantly. There's no warning, and it explodes. It literally explodes when it comes apart. And it can stress crack, so it'll be fine for the first 10 times, and the next time it just suddenly explodes. And this is what I'm a little afraid of. And
You see, guys, this one.
Ooh, that's pretty.
what do you got there?
Sugar GANs.
Sugar dance, okay. Just from what, caustic into sugar?
Yeah, lots of sugar, caustic, and you have this settlement. I washed it several times to get this coffee.
So that's pretty much basically just
And
real
this is
free. Oh,
And this is what?
salt.
see,
Salt, yeah.
Okay.
Pure salt. But, with, the NaOH process. So I collected this residual.
What some people call, they think it's CO2 GANs that they get from the salt, but it's probably a mixture of GANs. So what do you think it is?
No, this is pure salt.
Oh, just salt.
Yeah. I put salt, I put NaOH, the process, washed it, and this is the residual.
Salt and distilled water?
Right now, yes, salt and distilled water. I washed it 3-4 times. So this is the washed salt GANs. And this is washed sugar GANs.
So you get the both side of the pH.
You see?
Hi, Armin. Can I ask a question?
Yes.
So now that you've made the sugar GANs and you've made the salt GANs, am I correct to assume that the sugar GANs is magnetical and the salt GANs is gravitational?
Mm-hmm.
Okay, that's what
I want to try in this balls to rotate to see what's the effect I can get. But in true, you don't need all these motors to rotation. It's the fun part, to do it, but you don't need. If you have a right combination, they will rotate themselves.
If you'd like, I can show you my idea.
Okay, go ahead. Asma, you show me yours, I show you mine, huh?
Well, I'm trying. I'm going to try to
Microphone on.
without any power.
Well, this
Nice.
is,
Armin, did you use regular cane sugar or white?
Cane sugar. The brown sugar.
well, that explains the coloration then. I thought you were using white sugar and that had turned it brown from the caustic or something. Mm-hmm. So you have some molasses. You have some.
Yeah, it's not dark sugar. It's like
That's the.
the kind of color is different.
It'd be like the GANs of molasses, because there's molasses in the brown sugar. Okay, Mark, what do you have going there?
Well, within the last week here, it's been quite exciting for us to learn what Mr. Keshe has taught us. I just want to say happy birthday to him first off. And what I'm doing here, what I'm trying to do is something without power. So what I just asked Armin about was the salt and the sugar. Well, I'm treating these. I bought these bowls. They're 16-inch diameter bowls. I've got a nano-coated copper ring inside a nano-coated tubing. And then on this side, well, this one will be my NOA, which is I've been putting NOA salt or caustic solution in here and just letting it set in the sun. And then in this one, I've been putting salt in it and letting it set in the sun. And then what I'm going to try to do, because I'll have rings at the top and the bottom, like here you can see, I have a ring, a copper non-coated on the top and nano-coated on the bottom. This one will have the nano coating on the top and the non-nano coating on the bottom. So now, if you look at it, I've got salt on the top, NOA on the bottom. NOA on the top.
Why?
NOA, you mean NaOH, I think.
Yes, the caustic solution.
Right, NaOH, right.
Okay.
Gotcha. Just
yes.
wanted to be clear on that, that's all. Thank you, go ahead.
So I get a gradients of both of them from top to bottom. And then like Mr. Keshe said, what we're trying to create is a figure eight here and here. So like I said, there's nano coating here and there's nano coating here, non-nano coating, non-nano coating. So that's just the start of the setup of the container that I'm going to try to use. Then we move into the GANSs that I've figured out what I think is needed inside it. Then what I'm going to do once I don't know if we have the time, I could explain everything, but the next process that I'm going to have inside it is I've made these rings. I made 3 sets of rings, and each set is a little bit different size. Okay, so each set's going to have 3 sets of 3. Each set of 3 goes along with the GANSs. And now I've learned what the GANSs are for, because like we've learned, the CO2, the CH3, and the CuO are our 3 main GANSs we're going to use. So those 3 GANSs will be in the rings in in the various sizes. The 3 together in combination will be in one side. And then I never even realized that when I made all these, that I did everything in 3s. So now I have this set of 3s here they were made together, but in a different way. Like I had metals inside the container.
Let me introduce or finish a bit, because don't mix CH3 with those GANS.
Oh, we're not supposed to shoot. No, okay.
Because CH3 it's acidic.
Well, I thought
Alkaline. How if you mix together in those rings, so it's the same.
No. The rings will be separate. These will be separate. Each set of 3, you know what I'm saying? Like 1 CuO, 1 CH3, and 1 so I'll keep them separate in the rings. But then what I've been making some GANS water of the 3. Like I got 5 gallons of each that I've made the waters of these 3 and the waters of these 3. so that they could be the gradients of the different two. Does that make sense? I'm not going to put, you know, these will all be mixed. So now you made me a little worried because I did mix the CH3, you know, CH3 with these three to make, because at 2 weeks ago, we were told to put all our GANSes together to get a big mixture.
Not CH3.
All, okay. Well, I can start that part over because that's just the water part.
CH3, it's your, you remember we talked about power of hydrogen.
Yes.
All of this, what you have, it's an oxides.
Well,
Yeah,
I mean, I can, my readings on pH on all of these were made within 30 days, and I've got exact readings from start to finish for 30 days, and I can tell you exactly what the pH is on each one of them.
So what is the pH on each one of them? Tell me.
Pardon me?
What is the pH on each one of them?
Well, you asked me which one you want to know, like this.
Okay. Let's say copper. What's the pH on copper?
Well, on this one, this is the copper here. When I first started out, 720 or 7.2, it started out at 8.3. And then I 7.5. It was 8.4.
No, after wash, I'm talking the after wash. Whatever you done doesn't matter. After wash.
Okay. So after I'm completely finished, after 30 days of process and 5 washes, it turned out to be a 6.8. And the same thing with the CH or the CuO2 next to it, but this one was made with the tubes outside for the 15 days, and then I reversed the process. I don't, you know, if that made any difference. But here's the number for this one that's next to it, and this one even started. All the numbers were high, but this one right next to it now is the same thing. It's 6.8. So I got both of them exactly the same, 6.8.
What is your distilled water pH to start with? Is it always around 7, or is it less than 7 sometimes? Or
Yeah, no, this, I don't know where it comes, you know, it's a big box grocery store, but
they do
it
vary
starts
quite
out
a bit,
at
apparently.
7.4. Some of them were like 7.5.
Okay, so it did start out more alkaline than the than your copper oxide ended up.
Yes.
Okay, thank you.
So now the CH3 that's in there, it kind of worried me. Now you got me worried about that. But I could change that now to use in the bottom here, because what I was thinking was, if I had the gradients of these three in one side and these three on the other, with the complete, the real in the rings, and then in this side I have rings that are all have that are being nano coated. So I'll mix some of the nano coating with this. Can
I ask you one thing? You know, let's go to understand about pH and about you know, what kind of GANS you have, that you understand which mixture you're going to put in.
Okay.
One thing, hold it for me. Look, this is my pH meter.
Yep.
Okay, I just put it in a water to test it again to show it to you. 1 minute. This is all my mixed GANS. I have a lot.
Okay.
So if I put it here, look the reading.
Oh, I got the little things in the way. I can't see it. Shoot. Could you?
11. 11. If you leave it longer, it goes 11. Because I tested, I know, I just want to show you quick. So this is 10 point something, 10.8. Wait a minute. This is all the mixed GANS that I mix it together, but not CH. All the oxides.
Even like the titanium and nickel, or
Yes, 1 minute. we wash this. It's calibrated, this one, very much. The bigger bottle of the same, it shows approximately 6.9. So what I want to show you the difference between, you know, all the oxides, whatever I had, and maybe 25 of them, 27 of them. So without CH, it's almost 11.
By the way, Armin, you have a very nice measuring instrument. What's the pH of the sugar solution in distilled water?
I just made that, you know, I just washed it, you know, 3 times.
Because I see in sugar the number of oxygen atoms and the hydrogen, it just shows that it should be neutral.
I'll measure that, Sandor John, and I will let you know.
Thank you very much.
Or I put in proper containers like this. This is easy washing in that small containers. And
It seems like the sugar added to, say, an alkaline solution makes it more acidic, though, right?
Yeah, you provide more hydrogen.
Mm-hmm. Which, by the way, Guy and I were discussing earlier about this hydrogen thing, the so-called power of hydrogen and so on. And we talk about the ions in the solution. The way I was taught is the H plus the OH minus, and which is the hydroxide ion, the OH minus. So it's basically the hydrogen is the proton. The H plus is the core of the hydrogen atom. The H, but it's without its electron, so it's H plus. But apparently, it's not the case. Recently, the scientists that are supposed to know it all have decided that it's actually H3O plus, not H plus. So it's a whole different organism, you might say. It's not just these free protons, but actually a charged, more or less a molecule, the smallest molecule. And I thought that was surprising that they admitted that it wasn't really the way the theories have been for the last 50 to 80 years or whatever. It's actually a little bit different. I went, wow, that's quite amazing. They would even apparently it's very hard to measure. You'd think it'd be easy to measure these ions and so on, and we do have ways of measuring them, but they're not direct. Measure according to conductivity and that kind of thing. We can't actually grab the little buggers and put them under the microscope and say this is the hydrogen ion that's in there. So these ions are interesting. They're basically they're the ionized hydrogen. They're moving around inside this liquid. And that's an incredible idea in a sense. It's a miniature plasma inside there. And it seems like the more acidity, in a way, the more mobile these hydrogens become, more prevalent they become. So anything else to show us there, Armin, or comment on that? What do you got?
What I'm saying with that, you can try to with CH add sugar in it, sugar GANs in it too. You know, see what's the difference. I just made the sugar GANs, so I just want to try to measure it to understand it.
Mm-hmm.
You know how I can make this tool's not going to measure what we want to measure, but still it gives us an ideas.
Mm-hmm.
You know, let's say here. I just want to see. Just move this today. How we can measure, you know, plasmatic field. You know, it's hang here.
Mm-hmm.
You know what's this? It's a very nice idea. You know, I just went to hydroponic shop. You know, and this is what I got. See, it's light inside.
Oh,
Oh, nice.
little LEDs have the right frequency.
They do this for clones, you know, to
Mm-hmm.
transport it. You know,
Mm-hmm.
so it's a closed environment.
Mm-hmm.
A light on that, you know, they cannot damage the clone, whatever. And I found it. I said this is going to be very good to hang the ball. And what I want to see if any loading, I can make this ball to move.
Mm-hmm.
Or what I'm going to do, I'm not going to put GANs in it. I'm just going to put only liquid of it.
In the center ball you're talking about, inside your little contraption there?
Yes, still I'm going to make a acidic and alkaline, let's say, what we're talking about. But, you know, and I will try to bring a ball near if I can move this because it's all plasma. You know, this is all nano-coated. And the liquid is plasmatic too. It's a GANS liquid. So, and let's see if we can make a movement, any physical movement. You know.
Maybe on a circular pattern.
Circular or bring two balls together or move other ball together, this it will affect. If we can do that, let's say if I have one more ball here and I move this ball here, or I move this, no, not this one actually, I have to move all this too. If I can make any movement on this, you know, you have to do it perfect condition actually. So these are just the visible things that you see, you know, what kind of loading of your reactors you have. Then if you're going to bring, you have a magnetical ball, or you created magnetical ball, you can measure it, or you created acidic. Actually alkaline. So these are small things that we have to come up with the ideas how we can measure to show people. Okay, this balls, let's say if you make a one mixture, not every mixture, every ball, it's going to be the same mixture. It's impossibility. You know, they're going to be slightly different.
Mm-hmm.
If they are connected, it will show. You remember always plasmatic motion between transfer to mechanical motion. And I'm building my reactors.
Your twin, triple core.
Can we have a glimpse? Yes, yes.
Uh-huh.
Trying not to do with the motors. I have it, but I will try to
With no motors?
Huh?
This one is without any motors?
Without any motors.
Nice.
Okay. It looks like the GANS is moving to one side of the balls there. Is that the way it is, or is that an optical illusion?
No, it's not optical illusion.
What do you explain that to? it likes you?
When you shake it, you know, you just put it, you know, like this, and when they just when they settle, they take a shape.
Yes.
And they would take.
Do they always sort of gravitate toward you?
Actually, I never paid attention.
Well, you should pay attention to your GANs if they are doing that.
If
They're
I
saying,
paid
they're
attention, yeah.
saying, "Daddy, Daddy," and you're not paying them any attention.
That's a good one.
Well, they do. Well, it's just the angle here. I don't know. They look like they're reaching out. It looks like the GANS is building up on the side that's facing you there is also. It's interesting. Okay, any questions for Armin, or anybody have something else they want to...
Armin, I have a question. Earlier you were mentioning about your coil has been coated with aluminum.
Aluminum.
Sorry, can you say that again? I'm
It's not coated. It's aluminum itself.
Aluminum wire.
Oh, the coils themselves are aluminum.
Yes.
And you were mentioning that it creates a gap on an atomic scale. Can you explain, or I don't know if I heard that well, but this is where I got a hard time to understand.
Here, no problem. I'll explain. Let me go here. Okay. You open this quite frequently to understand. Numbers we see, we understand the difference between one material to another by atomic mass. Correct?
Yeah.
Okay. So if you open aluminum, it goes to 26 by atomic mass. So my question to you, if you go here, where is it? We passed it. Yeah. Isotopes. This good one. Go aluminum 19. Aluminum 19. We got to understand one thing. See, even aluminum 19, there is a trace of aluminum. But aluminum is 23, 24. So just imagine if you go up, aluminum, it's 42. But if you go to same thing, to copper, and we go to isotopes. Look, copper starts, its isotopes 52.
Mm-hmm.
So look the gap that it has to jump, 42, 52.
Oh, okay, yeah. The difference between the highest and the lowest of the other one.
That's if you go and find, let's say if we go aluminum and we go silicon, I just want to see 1 minute myself to understand. Yeah, silica starts from 22 and goes 44. So it will be approximately nickel. Let's see. What I want to show you about the isotopes, you have an understanding that any material, this one, it starts with 48. So you have to know where it starts and where it ends.
Okay.
You know, and then you find a gap in between. And between aluminum and copper, it's a huge gap to jump. That's why you have more powerful system.
Okay, I see. I start picking up the concept here. Yeah.
And when you say you can create a copper to the gold, if you go to the isotope, you know, and it goes to the copper, look at the copper isotope where it goes to 80.
It's a really high.
Okay, and where the gold, look,
Oh, yeah, okay.
205.
Wow.
If you have a gold, wires, and you can put the gold wires, you will have more powerful system.
Because the gap is greater.
Yes.
So we can actually choose from the lowest of the metal we can and just rub it against the highest metal we can in this chart, and it would make it extraordinarily powerful. The more you do that, or
Yes, you can do combination of silver and copper. You will get totally different interaction. But if you do the copper is copper, it's the same. It's powerful still, but it's the same. But when you make a gap difference, that's whole totally different game. You don't need to do all of them, just one. Out of the 4 interactions, see why is this? It's my understanding. If you can explain it differently. Magnetical and gravitational. 2 fields. Magnetical, gravitational, and magnetical. Just as if you have your coils, if you take one wire, it's one you consider it's gravitational, one it's considered it's magnetical. Because of the gap, this one is 80 turns and the other ones is 188 turns. Why? Because you have more interactions now. This is the gap. You always create a gap to have an interaction. If we stick all together, we can't move. There is no interaction. If we stand, far away from each other, we can do a lot of other things. This is the point. So you need to create a gap. You create a gap in your metals. You create a gap with the distance. It's all different. You can test it and you can see what kind of performance you can get. So this is the idea that if you don't understand these things, just go this periodic table and start to understand what material is what is the power of it, where it starts, where it ends. That you can make the connection. And your connection is carbon. Others are all oxides, CO2. And why you make a mixture of GANS? To have what? Soup? No, to have a different, higher, gravitational field. Because it's alkaline. You see it, it's almost 11. It goes to 11.
Appreciate this. Thank you very much.
You're welcome. Just understand, we need to different GANs interaction to have that gap, because each material have a different gap.
Alrighty, thank you, Armin. Is there anything more you'd like to add to that, or anybody else have a question for Armin? Okay, how about Lee Coates? Were you done with your presentation yet, or is there more we wanted to see about that?
No, I think I'm done. I do have, I am a little confused. Maybe Armin can help me out. All these different, when you build something like what I built, like should I be nano coating all my acrylic plastic trays in here and stuff? Like the other 2 or 3 weeks ago, Mr. Keshe was saying on his PVC tubes, he'd fill them with caustic inside, but he wouldn't nano coat them outside. So I'm just a little confused. What should I nano coat and what should I not nano coat as far as the structure
Let me ask
goes?
you a question. If we consider plasma is higher strength, what matter is doing there? You know, the field is going to cross the matter. Correct? Hello?
So we hear you.
You have a higher strength. You don't worry about the lower strength. Because now you have a plasma, that's why we did the separate, from material to nano into the gas. Now we have plasma in our hand. Now each small particle, whatever you see, you're calling atom, molecule, by itself, it radiates, magnetic field. Because they are entity now, because you can see they manifest it inside. Actually, we release them inside in a water that we can see. It's a small particle, but that small particle is or CO2 or gold GANS, whatever was in the environment, you released it. So you release the material more free. Now, as I explained, if we hug each other, we cannot do much. But if we stand in a distance, we can run, we can, do whatever we like. So it's the same thing. Now you released it, now you imagine it's a power of the same. That's why we look at the mass, what the mass is of that material, to have a little bit understanding what kind of plasma we're holding. Could I have explained? Or no?
Well,
I'm still not too clear.
Okay, so ask the question that I know which part is not clear. I'm listening.
Yeah, I'm not. I'm just trying to think.
Let's go one by one. We don't understand nanomaterial. We don't understand GANS. Which part we don't understand that we can close the loop?
I guess my question was about nano coating the acrylic or the PVC pipe or
you don't need that. If you have plasma, that's why I said, if you have plasma, you just don't need that, because matter is just, a tool.
Okay, so I don't have to worry about nano coating my structure, is what you're saying.
No, because now you have a more powerful, plasma, which is matter, is just holding it. That's all.
Okay. If I was to enclose this in a plastic covering or something, like put this in a 5-gallon bucket or something to, as a cover or something.
Then you have that environment. You separate it by plasma, by matter. So now you have to have a filter for that to pass on. Look, what is matter? What you consider matter? If I cut this, white board, I will have that material, whatever board is made of, correct?
Correct.
So let's say this made of CH bond, which is plastic, more common thing that we have. So that means, all these molecules, in atomic structure, we can separate carbon and hydrogen. In molecular structure, it's all mixed. It's all tied up together. Correct?
Correct.
Okay. But it's the part of all this material that you see. But it's in a bigger state that you can hold it, you can twist it, you can do whatever you want, because these all small things in here, they are stick with each other, they are hugging each other, so they cannot do much. So you are the stronger, so you can bend it and you can do whatever with them. But a minute you release them separately, go by atomic mass. If carbon is 12, correct, have 6 protons and 6 neutrons, correct?
Correct.
Okay. So your atomic mass is carbon is 12. Now, if you have a copper, it will be 63. You have a difference between 12 and 63. The gap is big, correct?
Yes.
Okay. So now in atomic mass, this one, which is copper, is higher than this. But if they are in soup, like in plasma soup and water, which we know that we transfer, every information what the copper has into the water. So the same thing, now we add to the mass. Now I will consider this 70, 80. I'm just explaining very simply that you have an understanding how you add it. Now, if you go by atomic mass of any other entities, let's say if you go gold or you go mercury, is 200. Lead is 207. The gap is huge. Now, if I have carbon GANS, copper GANS, and lead GANS, my total plasma field is going to be, let's say, 300. Now, if you have a plasma ball which is only carbon and, 1 minute, carbon and let's say aluminum, my plasma is going to be more higher than yours. Do you understand?
Yes.
Okay. So if any part of in this mixture, or you mixing it together in your soup, whatever mixer we have, we just consider this, what we have, what kind of materials we have, and what kind of atomic weight they have, so we know approximately what kind of power we are holding. That's all. This is for the GANs. But if you want to understand what is the matter is doing. Matter is the same as the plasma, but in a lower state. So you nano-coat it or not nano-coat it, now you're holding the plasma, it has nothing to do with it. It will pass through, just it was nothing. Your trays are just positioning of your, coils. How, what gap you need them to sit together. So rest of it, it's just a structure that you're holding the plasma together, because they are higher field than any matter field that exists on this planet. That's all.
Thank you, Armin.
You're welcome. You don't need to nano-coat them. Just, create proper mixture of your GANS and open up a plasma. You will see that it will be no difference. You have matter over there just for a structure to hold together. That's why we have sphere in a sphere in a sphere. Why we have that? Because we have different structures holding together. We put one inside another one, and inside another one. By field, they're mixing together, but they are separated. Positioned.
Hello, everyone. This is Alper from California.
Okay.
Hi, Alper. How you doing?
Good, thank you. How are you?
Good.
Just arrived. We've been traveling for the last 24 hours from Istanbul, and very tired. But as soon as I saw the, well, I know today is the day, and then I just turned on, and there you are, and I'm so happy to be here, back home after a month. I just wanted to say just a little something about manifesting. Something really interesting happened in terms of manifesting and thinking about it, and it's just appeared. What has appeared? Let me tell you. I've been dreaming since I started playing with CH3, with CO2 sphere within sphere. Things have changed, interestingly. I hope you wouldn't share this public, because something really interesting happened, which was I was dreaming about our government's change, and I was sort of seeing pictures, bit by bits, that things were happening, and I wanted it so much for the peace, because I know the background and everything about our country. This is just something where I have gotten this idea, which was Mr. Keshe said, don't play with the crumbs. So I wanted to really try it and really go for it. It was a dream, and that dream has become reality when I was in Istanbul. And this was a shocker for everyone. Nobody knew, and still they don't know how it started, why it started, what was there were many stories about it, but nobody knew what it is. This is something it was like holographic. It's like telepathy. I have imagined so much detail about it, lived it through many days, many nights. that was an experiment. And this experiment, my friends, it is so real. And I don't know what else to say, what else to add to it, but it didn't work 100%. There were other fractions that I didn't count. I didn't think about it. I didn't imagine enough or dream about it. So as we all work from the totality, since I'm here, back in America, and so much change is days ahead. We all dreamed about it. Collective consciousness has become the reality, a majority at the moment. So much intentions, and our hearts are beating for that, for every word that we say CH3 or CO2, it's all about peace. Oh, I can't believe this, really. I don't want to sort of magnify it with the usual words like I can't believe it, amazing, but it really is. I don't know what else to say. But one thing, it is very important that I have understood. Some countries, it's a second nature, but some really don't know anything about it, is that, is actually controlling the thoughts. I've been thinking about it since I've started playing with manifesting and experimenting nearly 2 months ago, consciously, with the help of the GANS. Simple as that, really. It magnified everything within me, and there you go. But the good thing is, do not just satisfy with the crumbs. There's a big giant, it is so giant. And I was thinking about how can I control my thoughts. And the thing is, I don't want to control my thoughts, really. I mean, I really don't want to, because my thoughts are beautiful and I love them. And just focusing on one thing in terms of traveling and just anything, rather than thinking about that and sorting all the departments in my mind and thinking, okay, I can control my mind. But our departments are so liquid. If you can solve one thing about you, that will be another aspect of you will get affected by it, and you won't be able to control that. So, like, how can I do that? And I like that reaction in me as well. Why would I control my mind? And it's Mr. Keshe, really. He's always talking about the totality, and I was thinking about what would be the totality of our minds, and I come up with the planet, Earth. Beneath us is us, and we're not part of it. When we say that part of it, it's separation. We are Earth. And when I thought about that, it collapsed everything. It sort of hugged all my thoughts, and I released it's like tons of sort of things off my shoulder. It's just like I felt really free. That added so much to me. All the departments of me has been like, I am the Earth. That's it. Earth is changing. We know it. Physical effects, we see it. Polar shift, so on. I don't want to go on about it, but all that I consider the Earth as a living being. So emotion of the Earth, soul of the Earth, is actually changing into something what we're experiencing. Us, part of the Earth, physical part of the Earth, is exactly the same. We are Earth, we are evolving, we're changing. That made everything so clear to me in terms of I don't need to change my thoughts. I'm the earth. I can just be relaxed, and I didn't think about anything. It's just sort of, I don't know how to explain it. Relaxation, really. It just lifts everything off my shoulder. Just believing into that. When
I am sorry, guys. I have to leave. I'm gonna go to the meeting.
Yes, I should actually go to the manufacturers meeting myself as well. I see
excellent. Okay.
Mark has his video on. Did you want to show something else there, Mark, other than your lovely lab setup that you have here? Not hearing your audio, sorry.
Hello, guys. I have to leave.
Okay, thank you very much, Armin.
Yeah, thanks, Armin.
Thanks for answering some questions there and showing us your stuff. Excellent.
Thank you, Armin. We really appreciate all that you contribute to the foundation.
Thank you.
Yeah, we have a bit of a conflict here. There's a manufacturers meeting, and I'd actually like to attend that. I'd like to find out what's going on that way. Was there something else you wanted to show, Mark, or did you have something else? I know you have probably several things you could show, but
Right.
Is there anything that is extremely interesting in terms of, have you gotten any rotation from fluids or anything like that that's popped up for you?
No. I'm still working on my
Your setup.
we only learned about that just a couple of days ago, and I ran out and so.
Great.
But I had to stop what I was doing.
I was thinking for the Knowledge Seekers workshop on Thursday, this is a great sort of test ground for anything that might be a bit revolutionary or a breakthrough. Basically, is what it'd be great to show it on here, and then to sort of run through the to make sure it really is a breakthrough and not just some sort of phenomena that's already known to science or whatever.
Exactly.
And that kind of thing. It's a good, I think, a good avenue for people to show their stuff, and we can brainstorm it and criticize and compliment and all that kind of thing to keep it going and try to get things set up for the Knowledge Seekers workshop on Thursdays, which is coming up shortly here, actually. But maybe by then you will have some rotation to show, Mark. You've got some interesting apparatus. I like the idea of the rings, upper and lower. That's definitely something to consider, I think. It's a very good idea.
It's just an idea. Because Caroline told us to try to get something to work without motors.
Mm-hmm.
But I just wanted to try to get some things going without motors.
Mm-hmm.
And I wanted to try to promote something that with motion, like we're all trying to do with motion. And Armin just told us that he kind of scared me a little bit about the CH3 in my mixture. But then as everything was going on and everybody was talking, and he was telling us about stuff, the thought process came into my head, which is CO2 and CuO combined with CH3 now makes a motion, because he said that it's not going to be where just there's 2 plus 1. The two higher elements are the CO2 and the CH3, or the CuO. The CH3 is going to be the bottom. It's going to constantly want to keep doing this because it doesn't want to be together with one another. So therefore, you already have a rotation by the 3. So that was my thought process. And I don't want to take up any more time. You got more things to do.
No, that's a good way to approach it. Go ahead.
This is Denny. I want to thank Lee, and I want to thank Mark, and of course Armin's already gone. But Lee, that's quite impressive how you quickly put that together and the thoughts involved, and also took the knowledge that Mr. Keshe said and filled up the PVC tubes. Now I think you, with a little extra stuff, you might even be able to get rid of your motors.
Yes.
Because of the things that you've picked up tonight. I'd like to see how you do that, because you're pretty prolific on making things, Lee. So I thank you for that.
So there's Lee and then there's Mark here now as well. I think, Mark, you've done the same thing with your posts, haven't you?
Yes, but I learned one thing, and maybe I could pass this on to Lee real fast before we go.
Mm-hmm.
Mr. Keshe told us not to mix everything, and in my unit here now, I learned how to cap off each one. So in each one of these now, it doesn't, you know, we make a field now instead of letting all the stuff mix together. I learned that you could buy caps that you can glue inside the PVC tubes and they'll stick real nice. I got a tester, I just smashed it real good and it didn't come out. So if you just kind of see in my thing here, the GANS waters that I'm going to fill in the tubes, Denny, or Lee, it'll only fill up to here, here, down to here, down to here, and it stops. I got a cap here and a cap here. So then I turn it, I start it here and let the water go down again, and it stops here and stops here. And here it is. These are the little caps. I got a cap inside here. And see, when you put it in here and put the cap like this, can you see that, everybody?
Yeah, can't see the cap itself.
It's black. Yeah. And these are just furniture ends, Denny, or Lee. You can go to the hardware store. These are little push-in ends for the furniture pieces. No, they're plastic. They're real cheap.
Okay.
Okay, so then that way you don't have to worry about any of the GANS water, so you can get as many different types in the pipes as you want. And then you just, you know, put your caps on and then you got a nice field. That's what I was thinking. And now I got a four based field here. So anyway, good night. I got other pipes though, and Denny, I'm just gonna give you this teaser because this is not all of it, but if you can just kind of get the idea.
Yeah, you got your stand that goes with it.
Yes, you know what it looks like, don't you? You can see it in your mind.
Yes. And so now one of the other things that Mr. Keshe talked about was the hot melt, the glue, and the caustic within your tube along with the CH3, as well as the ground up Coke.
Denny could, if Rick has to leave and wants to go to see, could you continue on with the session for 15 minutes and I'll put it together for you because you told me you wanted a little teaser.
Well, Rick, it's up to you. I don't know how to do it. You just. Well, you got all the live stream stuff and you got all that. I have no idea what to do with that.
We'll let it go. But you know, I can build the unit builds onto itself, and now that we've learned that we need more than just one unit, I made two of these, and I've made two of these, and they're offset. I've got another one that's a little bit bigger. You know me, a bigger is better, but.
Whoops, my other microphone's off, but I was just saying.
$5 I couldn't help myself. I had to buy.
Yeah, it's a cheap reactor basically. Yeah.
It's a cheap experiment, and I hope it works. And this is an experiment too, and I hope it works. And I understand the fields now, and I kind of 125 was the best lesson I ever learned out of all 125 lessons. When 125 came, I mean, I wrote notes. I know exactly now what I need to do. These create fields, each one of them. You don't want the fields to be together. You want them to be separate, but you want motion in them. in the pipes. You don't want that stuff on the outside because that's just the matter that holds it within it. It'll come out after that plasma field works in the pipes. Man, that stuff's just going to come out. These are going to start rotating and come out, and they're going to engulf themselves without a doubt. And now I even thought more that these are supposed to be underneath them. I don't know that yet, underneath or on top. I'm not too sure
Ooh,
yet.
that looks right.
Does that look right?
Yeah, that looks nice. And the other one on top, and it looks like, you know, twin
I
test.
guess I could put the other one on the bottom, but I need two of them, don't I?
That looks good. Yeah, something like that.
Something like that. So we play.
You might need 4.
Kenny, you know what? When you see this put together, we're going to sit in it. This is what I made it for all the brothers to sit in. Or family. I think every family should have one of these in their home because if times get tough, the fields will, when I build it, you'll see it. If you got time or go or just tell me what to do. I'm kind of excited. I wanted to get it out. Today's the day, and I really needed to at least let people know this is what's happening here.
Right on, Mark. Excellent. Well, keep putting her together. We're looking for an effect of some sort, so we have to. We've seen lots of systems, but it's time. Like that's what I'm trying to focus on. I've got, you know, dozens of different ideas and lots of stuff that is. Oh, I should show my latest thing that showed up today. And let's maybe
you gotta watch your time there, Rick.
Yeah, I got to get going. So let's end things, but let me show my little thing for the ending here. Let me start my video and get it pinned. So I need lighting. We need some lighting effects here. I got this little device today. I'm a sucker for thrift stores, right? So I go in and right away I just gravitate toward this, and it's I think, wow, it's really cool. It's a sphere, and it's a sphere within a sphere. What could be better? And it's $1.50. I'm sold. I'll take it. I don't even know what the heck it is, and I drag it home. And you know, this is my home has become a home for wayward reactors, you know, that have any kind of possibility for rejuvenation or rehabilitation. I bring them in.
Maybe people has a question or...
Huh? Oh yeah, maybe you have a question that you'd like to get answered, because it turns out this is actually a crystal ball and it can answer questions, unbeknownst to me until I brought it home. So, does anybody have a question? It has to be like a yes or no kind of question. Something.
Okay,
really...
a yes or no. Can you be turned into a plasma generator?
Okay, I'll push the magic button.
By the power of the moon, I declare no.
What? Oh.
Let me ask a question.
Okay, please do.
Will this technology set us free?
That's the button.
Better answer will.
Ask me later. I'm in a trance right
now. Me too, honey.
Okay, one more question. One more question from anyone.
Are we gonna have better days in the plasma community to find new horizon for humanity?
Boy, that's a big one. Okay.
There's magic in the air. The answer is yes.
Oh, yes.
Woohoo! Okay, well, we finally got a yes answer out of her anyways. But I thought that was pretty cool. I had no idea that that would actually light up and do that and so on until I got it home. But I've got plans for it. It's going to get gutted and rejuvenated and made into something else because it's just too nice to not take apart. Nice in an engineering kind of way.
Well, don't hurt its brain and its soul.
Yeah, I know.
Or its emotion. Try to keep its emotion intact.
Yeah,
Soul intact.
it's its own little entity in there, and I don't want to disturb it in a way, but it's going to help the plasma cause in some sort of manner.
Yeah, remember, everything's alive.
It's as alive as we are. We can learn to be more alive, I think. Here's to life. Okay, I'm going to end things for today because I am supposed to be at another meeting. So, thanks to everybody. That was fun. And stay tuned for the Knowledge Seekers Workshop on Thursday. And bye, Mark. Thank you for your presentation.
All right, guys.
Hope they see more from your stuff next week.
Thanks for the good work and the fun. Thanks.
Thank you for being here too, Guy. Okay, I'm going to end the live stream.